Hi there and welcome. Thank you for joining me as always. So today we are adding fractions. This is something I've been asked about many times, so here we go. We're going to look at adding fractions with the same denominator, then different denominators, and have a look at one or two things to look out for. Let's start at the beginning and look at a simple scenario in terms of adding fractions. I'm assuming that the viewer already knows a little about what a fraction is and what it's describing. If you're not too sure about that, maybe take a look at my fractions basics video. But let's take a look at a fraction. So here we've got 1/5. So quite simply, something has been divided into 5 pieces and you've got one of them, 1 out of 5, 1/5. Now, if we were to add that to another fraction, 2/5, well, in this scenario it's quite straightforward because you've got 1 out of 5 here, you've got another 2 out of 5 here. All we have to do is add the two top numbers, so your answer is 3 out of 5. The reason that's been so simple, of course, is because the denominator, the bottom number, is the same in both fractions. So you are adding like fractions together. Now, where things get a little more difficult is when we're adding fractions that have different denominators. So let's have a look at one of those. Let's say we've got 2/5 and we've also got 3/7. Now, of course, you can't simply add the tops together because these are different fractions, different animals altogether. Therefore, in order to be able to do what we did in the first example, simply add them together, we have to reach a situation where the two denominators are the same. And we do this by using equivalent fractions. Again, if you're not sure about equivalent fractions, have a look at one of my other videos and it covers it all there. Equivalent fractions means that we need to make these two numbers the same. And there is an easy way to do this. Quite simply, the first thing we do is we multiply the two bottom numbers together. That, of course, 5 times 7 gives us 35. So what I'm going to do is create two new fractions. One is going to be the equivalent of 2/5 and the other is going to be the equivalent of 3/7. Once we have created these equivalents, they'll have the same denominator. So we need to ask, what did we just do to the 5 to turn it into 35? And the answer, of course, is we've just multiplied it by the 7. Now, the rules of equivalent fractions say that whatever we do to the bottom of a fraction, we also have to do to the top. So if we've done 5 by 7, we've got to multiply 2 by 7, and that gives us 14. So 14/35 is an equivalent, it is equal value to 2/5. On the other side, however, we've got to ask, how did we get from 7 to 35? And of course the answer is we multiplied it by the 5. If I've multiplied the bottom by the 5, I have to do the same with the top. 3 times 5 is 15. Now let's write these down at the bottom. We've got 14/35 and we are adding it to 15/35. Now we are in the situation where the denominator is the same number, so we can now go ahead and simply add the top two numbers together. 14 plus 15 is 29, and it's 29/35. Once you get your answer, we would normally simplify. In this case, we can't, so the answer stays as 29/35. I do like to use more than one example, so let's do this a second time. This time we've got 1/8, 3/8 and 5ths. So again, they are different fractions. We cannot simply add them together. So let's make the equivalence. We're going to do that by multiplying 8 times 5. 8 times 5 is 40, so we're going to have two new fractions, both with 40 on the bottom. Again, what did we do to the 8 to make 40? We multiplied by 5, so I'm going to multiply the 3 by 5. 3 times 5 is 15. On the other side, what did we do with the 5 to make it 40? Well, we just multiplied it by the 8. So on this side, we're going to multiply the top by the 8, and we get 16. So we now have 15 over 40 plus 16 over 40, and the answer is 31 over 40. Now, so far we've simply looked at the mechanics of how we add fractions together, and if that's as far as you want to go, that is absolutely fine. I just, however, want to have a look at a scenario where there may be other options open to you. Let's just take a look at this example. We've got 3/5 and we've got 4/10. Now, first of all, I'm going to use exactly the same method as we did previously. So the first thing I'm going to do is multiply the 10 and the 5. So in this case, we're going to have two new fractions, both with 50 as the denominator. As before, how do we get from 5 to 50? We've just multiplied it by 10. So the top is going to be 3 times 10 is 30. On the other side, how did we get from 10 to 50? We just multiplied it by 5. So the top is 4 times 5, which is 20. Now, if we add these together, 30 plus 20 over 50, we get 50 over 50, which happens to be 1. Now, we followed the same method here. We've multiplied the bottom two. But if we have a look at why we did that, what we are looking to find is a denominator which is in the 5 times table, but it's also in the 10 times table. We are looking for that common multiple of 5 and 10. Now, if I take this all the way back to the beginning, let's have a look at the two fractions in this particular special case. Instead of multiplying the two bottom numbers together, we can, if we're fortunate, realize that the number 10 itself is in the 10 times table, and it's also in the 5 times table. So actually, all we have to do here is take the 5 and multiply it by 2, because 5 times 2 is 10. We've multiplied the bottom by 2, therefore we can multiply the top by 2. 3 times 2 is 6. Now, we've got 6/10 on this side. We already have 4/10 on the other side. Add them together, 10 out of 10 is 1. So there are situations where sometimes one denominator is a multiple of the other. And in this case, we don't have to cross multiply them. We simply need to turn one into the other by multiplying one side only. And finally, let's have a look at a situation where there are more than two fractions. There are a couple of ways that you might be able to approach this. The first way would be to add the first two fractions together in the same way that we have done previously, and then come to the third fraction. So in other words, we would be multiplying 5 times 4, so that would give us two fractions with 20 on the bottom. We'd ask ourselves, what did we do to the 4? We multiplied by 5, therefore the top is 1 times 5, and that's 5. On the other side, how did we get from 5 to 20? We multiplied by the 4, so the top has to be multiplied by the 4, is 8. So we've now got 5 plus 8 is 13 over 20. Then we can add the answer to those two to 3/10. Now looking at this example, if you remember what I said earlier, this fraction has a 20 on the bottom, this fraction has a 10, therefore it is perfectly good enough to simply multiply this by 2, so that becomes 20, multiply the top also by 2, becomes 20, and we are adding that to 13/20, so our answer is 19/20. That's one way to do it. Again, I'm going to go back to the original sum again now, because quite often in an exam question the denominators are chosen in such a way that there is, if you like, a shortcut to solving this. If we have a look at these particular fractions, the denominators are 4, 5 and 10. We are looking for a common multiple, a number that is a multiple of 4 and 5 and 10, and hopefully without doing any multiplication whatsoever we can see that each of these numbers will multiply up into 20. So on the left hand side, 4 times 5 is 20, so 1 times 5 is 5. We're adding them together. In the centre, 5 times 4 is 20, so the top, 2 times 4 is 8, and the bottom one, of course, 10 times 2 is 20, so 3 times 2 is 6. So 5 plus 8 plus 6 equals 19/20. Always worth keeping an eye out for that possibility, just to make things a little easier. And that's it. Hope you found it useful. If you did, please have a look at my channel for some of my other videos, and hopefully I will see you again. Thank you.